Hi, good morning. I'm Dr. Pranavanand Satyamurthy, heading Electronic and Instrumentation Department. Today, I'm going to discuss regarding multistage amplifiers. As this is a part of Electronic Devices and Circuits 2 course. Now let's go into the subject. Two-stage RC coupled amplifiers. Now, in the two-stage RC coupled amplifier, we're going to work like how this RC component is going to couple two transistors. Now, here we are having transistor 1 and here we are having transistor 2. Now, if you see, the R and C is the one that is coupling the first stage with the second stage. Now, I'll explain each component of it. First, VIN. VIN is the AC power supply, and RS is the current limiting resistor. Cin is the input capacitance. Now why RS? RS is the current limiting resistor which is used to protect the further devices from here on. So any surge in the current will be handled by RS and it will be removed or probably reduced accordingly. Then Cin is the input capacitance. See, now we are working with the AC amplifier. In fact, now what we are supposed to do is we have to get only the AC component to the next stage. So what we'll do is we'll use a capacitor. Now the Cin capacitor is the input capacitor that is going to block all the DC components and allow only the AC component to the next stage. Now coming to this one, the resistance R1 and R2. This is used to create a voltage divider network. Now based on this voltage divider network, what we have is voltage divider bias. Once we apply this voltage divider network, so what we have is like what we get at the end is like we'll get R2 divided by R1 plus R2 into supply voltage, that is equal to the input voltage at this point. Let me say the voltage at this point is Vx. So Vx value is equal to this one, right? Now, once we know that here we have the base and this is the emitter side, once the VBE value, approximately if I consider this as a silicon transistor, it's going to be around 0. It's going to be 0.6 volts or so. So if I say the Vx value is going to be greater than 0.6 volts, then the system will start to work. That means this transistor will get on. So what is being fixing it? So R2 and R1, that is this voltage divider network, is what is going to fix how much Vx value is supposed to be. Now once you have the proper Vx value, that depends upon R2 and R1 value, then the transistor gets on, right? Now coming to this one, this is the RC network. In fact, the bypass resistor and the capacitor. Now I'll say you see RE1 is in parallel with CE. So if I write in terms of impedance, so it is going to be RE1 in parallel with 1 by j omega CE. Now in this case, what's going to happen is, see, they both are in parallel. Now assume that the frequency is very high. Let me take for example like this is nearing to infinite hertz. So now what happens here is this RE1 will become parallel to 1 by infinite, that's going to be like 0. So this is going to be approximately equal to 0. Right, a high value resistor in parallel with a low value resistor, the net resultant is always going to be the low value resistor. So this is one part, let's remember, and then let's go to the next one. This is RC. So this is actually acting as a load resistor for the first stage. After that we are coupling it to the coupling capacitor. Now the job of this capacitor is also very simple, to block all the DC component and allow only the AC components. Now again R3 and R4 has the similar job as R1 and R2, and RC2 is in parallel with RL. Now I'll say why it is in parallel. See, we have the Cout here. Once we are going to have the Cout value replaced by short for AC analysis, then probably RC2 will become parallel to RL, because while doing the AC analysis we will short all the DC supply to ground. Now let me say what is this DC supply and how is it related? See, let me check this. Yeah, the DC supply is very simple. It's like a battery. Now I'll take an example and I'll say you see the DC supply is the same as the battery of the mobile phone, and the V in that we are talking, the input voltage is the speed signal or audio signal. Right, now if we check this, in this case, at any point of time, the maximum power delivered by this transistor cannot be greater than the DC power, in the sense, so our PAC will always be less than PDC. Now how do we get this PDC? That's based on the DC voltage and the DC current that is being pumped in. So this is the foremost important thing about the transistor. Now why do we use two stages? See, I'll have the gain, let me say beta 1 for transistor 1, and let me say beta 2 for transistor 2. These two are the gain. So the total gain, if I take the total gain will be B1 times B2. If it is going to be ideal, in the sense case like B1 is equal to B2, then the voltage will be like, let me say B1 square or probably beta 2 square, right? So the intention is to increase the gain, the current gain as well as the voltage gain can be increased by using two-stage RC coupled amplifier. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.